Hello, my dear students. I think you have enjoyed my teaching. It is a long platform in YouTube, so I know I can cover it only with the help and cooperation, support of you only. So please do cooperate with me, and I think I can able to make you understand the topics which I am going to teach today. Okay, so let's start. That is acidity of carboxylic acids. Okay, acidity of carboxylic acids. It is a very important. Listen now. You know that compounds containing COOH group are called carboxylic acids. Compounds having COOH group are called carboxylic acids. Say if we consider a carboxylic acid R C double bonded OH. This is a carboxylic acid. You know that acids have a tendency to release the hydrogen ion when dissolved in water. Okay, when dissolved in water, acids have a tendency to release hydrogen ion. Now listen, as oxygen is more electronegative than hydrogen, so oxygen has a tendency to attract the bonding electron from hydrogen, and thus we get RC double bonded O negative plus H positive. When an acid releases hydrogen positive ion, it is called proton, and the negative part after releasing a proton is called conjugate base. So remember it, when a carboxylic acid is dissolved in water, it gives two ions, one positive and one negative. The positive hydrogen ion is called proton and the negative ion is called conjugate base. Can you tell me why reversible is there? Anyone guess? Listen now. If we consider HCl, whenever it dissociates in water, you write this way, H positive plus Cl negative. Why only one arrow towards the product? Reversible? Good. Any organic acids, whether it is aliphatic or aromatic, are very weak acids. That's why whenever they dissociate in water, it's reversible. Okay, they are all weak acids. Now, instead of R, if you put methyl, ethyl, propyl, any alkyl group, it is called aliphatic carboxylic acid, and instead of R, if you put benzene ring, you know that when benzene ring is attached to anything, it's called phenyl or aryl. It's called aromatic carboxylic acids. As it is reversible in nature, whenever it reaches at equilibrium, then listen, the dissociation constant of acid, that is denoted by Ka, equals to, according to laws of equilibrium, the concentration of product, this is product, okay, and the concentration of reactants are COO negative, and here are this one COOH. This is called dissociation constant of acid. Now it is in upper side, it is also in upper side. So it is clear to us that Ka is directly proportional to H positive. So dissociation dissociation constant of acid is directly proportional to H positive ion. That is, you can write greater the value of Ka, stronger will be the acidity. So we can measure the strength of an acid in terms of dissociation constant of acid, that is Ka. Greater the value of Ka, stronger will be the acidity. Understand, I think? Any carboxylic acid, when dissolved in water, it dissociates into hydrogen positive ion, and this hydrogen is released. Remember it as why? Because oxygen is more electronegative than hydrogen. That's why oxygen has a tendency to attract the bonding electron from hydrogen towards it. We can measure mathematically the strength of an acid by means of dissociation constant, that is Ka. In the law of equilibrium, we can write it this way, okay? In equilibrium chapter, I will discuss detail. So it is clear to us that Ka is directly proportional to H positive ion. That is, greater the value of Ka, stronger will be the acidity. Now, the reverse of Ka. The reverse of Ka is called pKa. Write down. The reciprocal of Ka is called pKa. So pKa equals to 1 upon Ka. You can write it. Actually, pKa has mathematical formula. In equilibrium chapter I will discuss, okay? So it is clear to us that greater the value of pKa, lesser will be the acidity. Greater the value of pKa, lesser will be the acidity. So in a nutshell, you can say that, okay, acidity increases if Ka increases. Acidity decreases if pKa increases, because Ka and pKa are just reciprocal to each other. Clear? So remember it, the acidity of an acid, carboxylic acid, can be determined mathematically in terms of Ka and pKa. Clear? Okay, now the next topic. Next, okay, next topics. The acidity of an acid depends on the tendency to lose H positive ion. Greater the tendency to lose H positive ion, more will be the acidity. So write down point by point the acidity of an acid depends on the tendency to release H positive ion, that is proton. So the acidity of an acid depends on the tendency to release H positive ion. Greater the, right one, right, okay, greater the tendency to release H positive ion, more will be the acidity. Greater the tendency to release H positive ion, more will be the acidity. Now, presence of electron withdrawing group that is electron withdrawing group increases the releasing tendency of proton H positive ion and increases the acidity. So listen, the acidity of an acid depends on the tendency to release hydrogen positive ion, that is proton. Greater the tendency to release H positive ion, more will be the acidity. Presence of electron withdrawing group increases the releasing tendency of H positive ion and increases the acidity. So, what are electron withdrawing groups? I think you all know electron withdrawing groups, okay? The electron withdrawing groups in decreasing strength are nitro. Examples of electron withdrawing groups in decreasing order: nitro, cyano, benzene ring C6H5, it's called phenyl or aryl. Nitro, cyano, benzene ring, it's called phenyl or aryl. Halogens X, that is halogens, it may be fluorine, greater than chlorine, greater than bromine, greater than iodine, and hydrogen list. So these are the decreasing order. There are others group also, no need in board exam, okay? Now, in reverse sense, you can say presence of electron donating groups. Presence of electron donating group decreases the acidity. So write down presence of electron donating groups, that is electron donating groups, decreases the acidity. Why? As the removal of H positive ion, that is proton, becomes difficult. If electron donating groups are there, they push the electron towards oxygen. But you know that oxygen has a tendency to gain electron. So the two electron cloud opposes to each other, and thus the releasing tendency of H positive becomes difficult. That's why acidity decreases. Clear? Remember, only presence of electron donating group decreases the acidity. Presence of electron withdrawing group increases the acidity. So what are electron donating groups? Write down alkoxy groups, that is OR, greater than alkyl group, that is R, greater than hydrogen. So they have a tendency. Alkoxy group, methoxy, ethoxy, propoxy called alkoxy group, methyl, ethyl, propyl called alkyl groups. Okay, so you know alkoxy group, alkyl groups, you know, actually I think you know because I have already discussed in my previous classes, that is basicity of amine. Still write down alkoxy groups. Example of alkoxy groups: methoxy OCH3, methoxy OC2H5, ethoxy, propoxy, etc. OC3H7, propoxy. These are all alkoxy groups. Actually, you will find it in ethers. Alkyl groups, you know better: ethyl, C2H5, methyl, CH3, etc. You know it. Now the next. So, can you tell me one answer? Okay, very easy. Now the question, this is very important for board exam. Which is more acidic? Which is more acidic? Aliphatic, carboxylic acid, or aromatic carboxylic acid? Can you tell me which is more acidic, aliphatic or aromatic? Listen, in your answer sheet, at first draw the picture, okay, structure. Aliphatic carboxylic acid. If the carboxylic acid group is attached with alkyl group, that is the aliphatic. Write down below it: aliphatic carboxylic acid. And if the carbon is attached to benzene ring, that is aromatic carboxylic acid. This is aromatic acid, and it is aliphatic acid, like carboxylic acid. So listen, you know that benzene has electron withdrawing nature. This is electron withdrawing group. I have already given. Any alkyl group has electron donating nature, so it donates electron, and you know that presence of electron withdrawing group makes the releasing capacity of hydrogen easier. That's why the acidity increases. But here, listen now, as oxygen has a tendency to attract electron, and here the R group also pushes electron in this way. So this electron and this electron may repulse each other. That's why some extent of electron clouds go back to hydrogen. So acidity decreases. Clear? Oxygen, due to more electronegativity, has a tendency to attract electron from hydrogen. Imagine one electron cloud is there. Imagine one electron cloud, that is for this. Now, from this side, the alkyl group, as any alkyl group has electron donating natures, it donates electron C. Whenever the electron cloud comes here, repulsion takes place. So some part of the electron cloud goes back towards hydrogen. That's why the releasing capacity of H positive ion of aliphatic acid becomes certain extent difficult. Hence we say that aromatic carboxylic acid is more acidic than aliphatic. But if this type of question will come in your board exam, it carries hardly 1 mark. So how to write the answer? Okay. How to write the answer? Now the answer is, write down the answer. How to write? The main answer in your exam, how to write it. This is R, COOH donating. This is benzene. You can write ring COOH. This is withdrawing. This is aliphatic. How to write the answer? Okay, aliphatic carboxylic acid, and it is aromatic carboxylic acid. Now it has electron donating nature, it has electron withdrawing nature. So directly you can write, okay, it hardly carries 1 marks, no need to write details. Due to the presence of electron withdrawing benzene ring, removal of benzene ring in aromatic carboxylic acid, removal of H positive ion becomes easier. So aromatic carboxylic acid is stronger than aliphatic carboxylic acids. I think you understand it, okay? Very easy concept. Presence of electron withdrawing group increases the acidity, presence of electron. And remember the name, nitro greater than cyano, greater than benzene ring, greater than halogens, greater than hydrogen. And presence of electron donating group decreases the acidity. So electron donating group, any alkoxy group which you found in ether, greater than alkyl group, greater than hydrogen. Bas. Now the next, I think you understand it, okay? So the next topic, next question. Now, question. Arrange the following in decreasing order of acidity. Okay, the question is, arrange the following in decreasing order of acidity, give reason. If this type of question will come, it carries 2 marks. This is exam question, obviously previous year's board question, okay? Now, try chloroacetic acid number 1, acetic acid number 2, dichloroacetic acid, say number 3, and monochloroacetic acid, say number 4. See the question, arrange the following acids in decreasing order of acidity. Decreasing order matlab highest acidic to least acidic. Sometimes in exam question they will give directly structure. Sometimes they used to give name, so that you should know the formula of the compound and then. Now, if we do not know, no matter. Listen, this compound contains 3 chlorine atoms. This compound contains only 1 chlorine atom. This compound contains 2 chlorine atoms. You know that halogens have electron withdrawing nature. Again, you know that presence of electron withdrawing group increases the acidity. And it is clear to us that greater the number of electron withdrawing groups, more will be the acidity. So, if you do not know the structure, even you can write the answer. Trichloroacetic acid contains 3 chlorine atom, so it is the strongest acid. Dichloroacid, 2 chlorine atom, next. Monochloric acid contains 1 chlorine atom, next. And the least acidic. Why? Because it has no electron withdrawing group, but it has electron donating CH3 group, so it is the least acidic. It is the least acidic. You can write directly. But if you do not know the structure, you can write. But it is better to know the structure, okay? Now, trichloroacetic acid it is. Don't write, listen. This is acetic acid. This is acetic acids. Follow the technique, okay? Organic. Only technique. Bus. No need to mug up. Only technique. Acetic acid. There are 3 hydrogen atoms. These are called alpha hydrogen, okay? These are called alpha hydrogen. How do we know? This is the carbon of carboxylic acid functional group. It's a functional group. The carbon of carboxylic acid functional group. The carbon attached to the carbon of the functional carboxylic acid group is called alpha carbon. This is called alpha carbon. And the hydrogen atom attached with the alpha carbon called alpha hydrogen. If you replace one hydrogen atom by chlorine, Cl, CH2, COOH, it is called monochloroacetic acid. If we replace 2 hydrogen atoms, see here, not here, if you replace 2 hydrogen atoms by chlorine, Cl2CH, COOH, it is called dichloroacetic acid. And if you remove all the alpha hydrogens by 3 chlorine atoms, it is called trichloroacetic acid, Cl3C COOH. It is called triacetic acid. So what is the explanation? The answer should be like this. Listen, I will write the answer, okay? Understand it. Now continue. After drawing the structure, continue answer, okay? As we know that, continue answer, okay? Continue answer after drawing it. Know that presence of electron withdrawing halogen atoms increases the acidity. That we know. So, greater the number of electron withdrawing group, more will be the acidic. Greater the number of electron withdrawing groups, more will be the acidity. More will be the acidity. Thus the trichloroacetic acetic acid is the strongest acid and acetic acid is the weakest acid. Thus the decreasing order of acidity is the decreasing order of acidity is trichloroacetic acid greater than dichloroacetic acid greater than chloroacetic acid greater than monochloroacetic acid. So trichloroacetic acid greater than dichloroacetic acid greater than monochloroacetic acid and greater than acetic acid. I think you understand today's topics. Okay. In another classes I will discuss the remaining topics on acidity of carboxylic acids. Okay, so please watch the next videos on the part 2 of acidity of carboxylic acid and you can understand everything. In the second part I will discuss the previous year's exam questions from board as well as some of entrance question also. Okay, so thank you for attending. Bye.